Again, we're moving into volumes of pyramids and cones. And all of these shapes all have how many bases? 3, 2, 1? Say it louder. How many bases do these have? 1. And they all have a vertex opposite that base. So you already made three-dimensional figures that included 2 pyramids and a cone. And we already wrote the formula for the volume, so this isn't something new to discover today. The only difference between a prism and a volume formula, and a pyramid volume formula, those two things, is we find the base area times height, but we don't leave it there. A pyramid must be divided by what? What's the factor we're dividing by? So how many pyramids would make up the volume of a prism of the same base? Here I have a hexagonal prism and a hexagonal pyramid. They're the same height. See that? They have the same size base. So how many of these pyramids could I pour into the prism and they would then be equivalent area? And your answer is? 2. It seems like 2. People say 2, but you're not. Actually, you didn't think too hard about that formula then when you wrote it on your pyramid. It is 3. Did you know you could pour 3 of these cones of rice into one of these prisms that has the same size base and the same height? Okay? So the formula is base area times height divided by 3. So let's try this with a real pyramid down here. Pyramids are named by their bases, so how would you name this pyramid? What shape is the base, in other words, right? Sophia. Are both sides that you see the same or different? So rectangle. So we would call this a rectangular pyramid. Everybody say it?
Rectangular pyramid.
Good. Okay, and so the first thing we notice is it's a pyramid, so we're going to begin with that formula. Let's say it as we write it. Ready? B equals base area times height over 3. Yep. Whenever we have base area, capital B, in the formula, the next step is to show the formula for that kind of shape, right? So Sophia said that this was a rectangular base. So let's all say the area of a rectangle equals?
BH.
BH, good. This H is the height of the pyramid out there. Inside of parentheses, we have the height of the rectangle, right, which is different, over 3. Okay, and now we simply substitute correctly. So tell us how to substitute into this. Give me the dimensions of the rectangle, Chet.
10 times 12 in parentheses times 10 for h divided by 3.
Good, he gave us everything, okay? And the units, be sure to check out if the units are all the same. You know, in last night's assignment, you know that one where you received units that were inches? What other dimensions did they give you? Feet and yards, all the different ones. So you've got to make sure they're all the same, okay? So this is all meters, so we're going to end up with meters times meters times meters, or meters cubed. Which makes sense, right? Good, so you can either simplify the whole numerator and divide by 3, or you could, because the numerator has all multiplication, you could reduce, like we could reduce this part here, right? Since it's all multiplication. How many times does 3 go into 12? 4, so we could take and make that 4. So we really have 4 times what? 10 times 10 is 100, so 4 times 100 is? 400, there you go. The volume is 400 meters cubed. So here we have that issue of units. It says, find the volume, but find it in cubic feet, and they've given us the dimensions in what?
Inches.
Inches. So if we're asked to find the volume in cubic feet, we can change it now, or we can change it later. When do you think it's easier to change it?
Now.
Does anybody think it's easier later? It's actually, I think most of you said now, and I think that is the easier time for 7th graders, really. Because remember when you converted volume things and area things, you had to remember to square or cube the dimensions, which a lot of people will forget. So it's probably best to convert now. So the question is, if this is supposed to be in feet, 12 inches equals how many feet? Everyone?
1.
Good, that one's easy. You got that. 8 inches though. 8 inches. We can put our little conversion factor together. We're getting rid of inches and going to feet, right? There's 12 inches in 1 foot. So we end up with 8 over 12, right? And what is 8 over 12 when you reduce it? Michael? Well, let's say 2/3 then. Okay? 2/3 feet. 8 inches is 2/3 feet. And we have that again here, 2/3 feet. If we had to put it in the form of a decimal, we would round it to 0.67. This is not rounded. The longer you can wait to round something, the more precise your answer is. So let's just leave it that way and see what it looks like when we put that into our equation. Okay, so volume of a pyramid, let's say it one more time. Ready? Volume equals?
BH over 3.
Base area times height over 3. Okay. Now, what shape is this base this time? Do you see it? The shape, let's say it, the shape is?
Triangle.
So this is a different kind of a base. So let's just put the area of a triangle in here, and it is?
BH over 2.
BH over 2. This is the height of the whole pyramid out there, and then over 3. Okay? Okay, so we're going to substitute what we know, and we know that, who can tell me the dimensions of this triangle base here? What would we say, Casey?
2/3.
We have 2/3 times 2/3, all over 2.
Yeah, close.
See? Okay, and then what's the height of the whole pyramid?
1
1 foot, that's easy, and over 3. Okay, and 2/3 times 2/3 is? See, this is interesting. You don't remember how to multiply 2/3 times 2/3? Equals 4 over 3. Do we multiply 3 times 3?
Yes.
Yes, we do. 4 times 9. I heard a few 3s. That's interesting. Okay. So we have 4/9, which is being divided by 2. I'm going to write it that way. Times 1, which I don't even need, over 3. When we times by 1, we don't change a thing, do we? Okay, so here we are with a fraction divided by a integer 2. So I'm going to write it over here. 4/9 divided by 2. Who can tell us what to do? Tessa.
Put a 1.
Okay.
And then cross.
When we're dividing by a fraction, Riley? We do what?
We look at the one that we multiply.
We multiply by the reciprocal. There you go, multiplication. Good. And notice now, we end up with something that can be reduced, right? 4 and 2 can be reduced. I have 2 2's up there, right? And we get 2 over 9 times 1 is 9. We get 2/9. And then don't forget that whole thing is divided by 3 again. This is interesting. Leaving these as fractions has allowed us to be more precise, though, than changing it. So we really have 2/9 being, this is division, right? Divided by 3. So we're in the position of doing that same thing again, aren't we? So how do we rewrite this? Let's say it together. 2/9 times 1 over 3. Good?
Yeah.
Okay. And so this is good practice. We need to remember how to multiply our fractions. 2 times 1 is 2. And 9 times 3 is
27.
27. So So we had changed everything to feet, so our answer is 2/27 feet cubed. Not even 1 foot cubed. Does that seem reasonable?
Yes.
Look up here. This is not even 1 cubic foot. If it was 1 cubic foot, we would have imagine a box that's 1 foot by 1 foot by 1 foot, right? This isn't even that. This is 1 foot by 8 inches by 8 inches, and it's triangular too. It's not even a square base, okay? So it's not even 1 cubic foot. And it's interesting they asked us to put it into feet, okay? Okay, and so now a cone. Now a cone is to a cylinder as a pyramid is to a prism, right? So how many cones do you think I would need to fill up a cylinder of the same height and base? How many? 2. Really? 2? After everything we've said? Are you kidding? 3. It's 3 cones, right? The problem with this wooden example is, look, are they the same height? So this is not the best example one. Okay, I don't even like to show it, but that's what I have here. So, no, you're going to divide by 3. Same thing. This is really the same formula. However, we can refine it, because what is the shape of all cone bases?
Circle.
So instead of writing base area, what will we write?
Pi r squared.
Pi r squared, the area of a circle. Okay? Okay, 1 cone and we're done. You have everything you need given in this diagram here. We have a cone. There's a little part here. There's this given with a little symbol like that. It looks like a chair. So what are they telling you there? Height is what? Perpendicular. They're giving you that little right angle to let you know that that is the perpendicular height. You know, they could give you the height of this cone out here too. They could say, this way is 3 feet. You know, that's another way to give it. Usually, they give it inside the cone like that, with a little perpendicular symbol. Okay? So we simply write the formula. Base area times height over 3, or pi r squared times height over 3, which is a cone, circular base. And Abby, can you tell us what the radius is?
Radius
Good, 2 feet. We're going to square it. And what's the height? Good. And all over 3. Does anyone see something that can shorten our time here? Chad?
Cross out of base.
Good. Because the numerator has all multiplication, we have the same factor in the denominator, and we can then call that 1. Or we don't even have to put a 1 because we have other stuff, right?
4.
So how many pi's do we have?
4.
Good, 4 pi's. And this is going to be in feet times feet times feet, so feet cubed. And so now we could use the pi button on the calculator.
It's 12. 56.
5/7.
That's a familiar number for us, isn't it? 12.5, does it round to 7?
Yeah.
7 feet cubed. Or you could leave your answer in terms of pi. This answer here is in terms of pi, right? Sometimes we leave our answers that way. And then if they say round to the hundredths, then you go to the next step and you multiply by pi or whatever. Okay? So you should be able to complete this assignment in class today. Okay?